So it appears that a lot of students are having trouble with this problem 1513. And so I've put up a couple other videos just about the basic algebra you have to be able to do to get through these problems. And this one's a little bit beyond that because it involves the general idea that we're really using equation solutions to come to an approximate solution. And we're either at that approximate solution with our first try, or we have to do a couple successive iterations. So let's work through this one. And I put up the problem, basically what it is. It's calculate the equilibrium concentration of sulfur, S2, after the system has reached equilibrium. So we need to fill in the rest of the ice table here. So the change is going to be, because it's 2HS, it's going to be minus 2x, and then this is going to be plus a 2x, and that's going to be an x. So at equilibrium, it's going to be 2.80 minus, I'm sorry, that's times 10 to the minus 4th minus 2x, and this is going to be 2x, and then this is going to be x, and so our equilibrium expression becomes, well, it is going to be products of reactants, so 2x, and that's squared, times x, over the starting material, the reactant, so it's going to be 2.80 times 10 to the minus 4th minus 2x, and that whole thing is squared, and so we got a lot of squareds here, and that means we're probably not going to be able to use a straight simple solution, quadratic or cubic or something like that. But one thing we do have going for us is that this is equal to a very small equilibrium constant. So that means we're not going to make very much product. So this loss of minus 2x is typically not going to be very large. We're not going to make very much 2x. We're not going to make very much x. We're not going to make very much x. So we can approximate this by just saying, well, that is small term. Now it's might not be right because we're starting with a very low concentration. But let's see where we go here. So let's just work this out. So this now becomes 2x, and that's going to be cubed. And I'm sorry, this is actually 4 because it's 2 times 2, and then x squared times x, so that's x cubed. So that's divided by now just simply 2.8 times 10 to the minus 4th is equal to, and that whole thing has to be squared, is equal to 1.67 times 10 to the minus 7th. So we're making the approximation that that's small. It's small compared to this 2.8. Now I don't know if that's true because, like I said, it's very small. But we finish the algebra now. Now there's going to be a big jump here because I just went through and did the steps. So I just essentially multiplied both sides by 2.8 times 10 to the minus 4th. And then I divided through by the 4 here. And this is what I get. And then I'm going to simplify that and put that on the next slide. So you'll see another jump. So I have just done the arithmetic. So I've squared, multiplied, divided by 4. And now I've got to take the cube root of both sides here is really what's left to do. So take the cube root of that, take the cube root of that. And when I've done that, my answer turns out to be 1.485 times 10 to the minus 1, 2, 3, 4, 5th. So that's my equal to x. Now I've got to go back in and plug that into my ice table. So I will do that on the next slide.